Alright, thanks, Chief. I'll find him in here. Oh, hey, I just got transferred over from Bristol. I'm your new partner. It's nice to meet you.
Ah, yes. Your nameplate came in this morning. Max Theorem, is it?
Yeah, that's me.
Now, your desk is over there now, if you don't mind. I have a lot of work I have to get done.
You're just doodling. It doesn't matter. So what should I call you?
You can refer to me as Dr. Ive for the duration of your stay with the squad.
Alright, so Ivy it is. Alright, it's nice to meet you.
Dr. Ive.
I'm just gonna go work on my... set on my desk over here.
Alright, get ready for your work here.
Alright, I'll do that. Hey! That's us! That's our first case together! This is great! Let's go! Hey, come on, what's taking so long? This is our first case together. You should be excited.
Where are my keys?
I got them, don't worry. Come on, let's go! Okay. Alright, Ivy, you can drive this time. I got the next one.
Not follow me, or else the hostage life will be discontinued.
Damn it! He got away.
No, I didn't.
What do you mean?
As he was trying to escape, he shot at me, but I did manage to get a tracking device in his car. Risky business.
Really? Well, perhaps you're not as useless as I thought.
Huh. Glad you feel that way.
No, don't touch me.
Okay. Well, Doctor, the data from the tracking device I got on his car should be coming in any minute now. Oh, here it comes. I think that's it.
Well, print it out.
Alright, it should be coming through the printer.
Well, that's horrible.
You've got to be kidding me.
What is it?
It only gave us the velocity.
No worries, we could figure out where he went.
Hey, Doctor, look what the lab just gave us.
What the? Where did you get that?
The lab. They're upping our ante so we can fight the disintegrator.
Well, no matter how cool that thing is, I think you should come over here and help me. Don't point it at me.
Sorry.
Come over here and help me.
It's nifty.
So, Doctor, what you working on?
Riemann sum, midpoint. Have you ever done one of these before?
No.
Well, it's simple. Come on over and I'll show you. You see, what you do is you find at the midpoints between each 5 minutes here where the value is on the graph. And by doing this, we can have a very rough estimate of where the disintegrator may be by making a circle on a map at the maximum distance he could have gone. So anywhere inside the circle is quite possibly where he could be.
So what's that math below?
This is me calculating the maximum distance he could have gone.
Oh, that makes sense.
Yep, and in just a few minutes we'll have our answer. 45.6 miles. Bring over a map.
So, Dr. Ive, can you explain to me what a Riemann sum really is?
Why, certainly. The official definition is, let f be a function defined on a closed interval of a to b. For any partition p of a to b, let the numbers c of x be chosen arbitrarily in the subintervals of x to the k minus 1 or x to the k. If there exists a number I such that the limit of p as p approaches 0 of the integral of k equals 1 to n, f of c k delta xk equals I, no matter how many p's and ck's are chosen, then f is integrable on a closed interval a to b, and I is the definite integral of f over the closed interval a to b.
So, basically, a Riemann sum is a good estimate of the area under a curve.
Yeah.
Are there different types of a Riemann sum, or is there just what you did?
Of course, there's different types. There's left, right, and midpoint.
And what's the difference?
Well, left uses the leftmost point on your subinterval, aka the first point of your subinterval. A right hand uses the last point of a given subinterval, and middle uses the middlemost point between them.
Okay, I think I've got it. So, a Riemann sum can be used to find the area under a curve, and we had velocity, which means that the distance is the area under the curve for velocity, right?
Yeah,
Alright, thanks.
not a problem.
So is that the maximum distance you would have been able to go?
Yes.
Okay.
There. It's the only place that makes sense.
It's the perfect place that he could hide the goods.
Let's get going.
Am I still going the right direction?
Yeah, so you should be anywhere in this area.
I don't know why you brought that thing along. Hey, there's a odd red wagon right here. Does that mean anything?
I don't know.
There's some paper inside. What if the disintegrator used this to lug the body and goods? Let's see what this paper says. It's a note from the disintegrator. Do you want to read this?
How can we read it? Let's see it.
It says I buried the body. And that this awful handwriting. It says that the hostage is buried and the goods is buried with it. We have to rescue that hostage. How are we going to know how much air they have? How much time do we have?
I know how this figured out.
How? There are some weird numbers.
Well, what I'm doing right now is I'm using integrals to discover the volume of the coffin that the disintegrator buried both the victim and all the money in.
Okay. So you're using the numbers he gave you?
Yes. These are the approximate dimensions of...
A standard coffin?
Yes. And using this, we can determine the volume of air and determine how much time the hostage has before they asphyxiate.
No, I hope it's a big coffin.
Me too. There's our answer. 3,840.048 cubic inches of oxygen.
So they have a little less than 4 hours. Or like,
I hope so.
So, Doctor, I was hoping you could explain a little more about that volume thing you just did.
Oh, well, certainly. You see, what I did was I used a definite integral.
This is an integral?
Yes, much like this one. Actually, exactly this one. To find out the area under the curve of the function that was provided to us by the disintegrator of the coffin. And this curved top of the coffin is the function, and down here would be our axis. And by solving this integral, we found the entire area under here. And then by multiplying it by the length of the coffin, we have our total volume.
Okay. So, how does this integral work to get what's in there? Is it kind of like that Riemann sum?
It's very much like the Riemann sum. It's a much more exact way of finding volumes and areas underneath curves, which is what we did here.
Okay, I think I get it.
Happy to help. Alright. Okay. I'll let him know. That was the police. They've recovered the hostage and the money.
that's good news.
Yep. But if we still hurry, we can catch the disintegrator. He couldn't have gotten far.
You're right. Let's go.
Well, looks like we've caught him. Don't let him get away. Come on.
Just like a math teacher, I'm gonna give these guys some problems.
Get to the back. Hang on, filter. Hang on back there. You brought that with you?
Yeah. What if he tries to get away?
It looks like I've reached my limit.
It appears that his pulse rate is 0.